Yeah, so a bit more live integration. Why not? It's super fun, isn't it? So let's just keep doing it. I'm going to go a bit slower so people can read what I'm writing, hopefully. We'll pick a random number. For those who don't know, we just pick a random number, 456 in this case. Then we find 456 in Madass's integrals booklet. Oh, banged it out right there. 456, pretty close. Is going to be x to the 4 over x to the 5 minus 1, or to the power of 3 over 2. So then we go into our whiteboard and we integrate, and we're going to have to check that this is right. So it's x to the 4, I think, over x to the 5 minus 1, or to the power of 3 over 2. Let's just double check that that's correct. If I can bring back, oh, there we are. If I can bring back my, I think it's probably wrong, right? X to the 4, x to the 5 minus 1 to the power of 3 over 2. We got it right, perfect. Now, what I'm noticing straight away, of course, is that x to the 5 differentiates to something that looks a bit like x to the 4. So if you make a substitution that's like u equals x to the 5 dx, then we can say du equals 4x to the 4 dx. No, it doesn't. 5x to the 4, you absolute muppet. So that's du, which means, of course, that dx is 1/5 x to the minus 4. I guess you could write it like that. This is a silly way of writing it. But in any case, what I'm saying is that this x to the minus 4 would cancel with that x to the 4. So we'd end up with the integral, sorry about that, we'd end up with the integral of u minus 1 to the power, I guess, minus 3 over 2 du. We've also got this 1/5 just sitting there, so I can put that out there, I guess. Now, this is very easy to integrate, I think. I'm not sure what these are. These are me trying to get the other page up. This should be pretty easy to integrate, right? Because we can just raise the power up to a minus a half, and we can divide by minus 2, right? Yeah, and then we slap that fifth in front, and I think that's pretty much it. Then we put the substitution back. And the substitution was x to the 5, so I think this is minus 2/5 x to the 5 minus 1. And this didn't require a substitution at all, right? This was not, I don't think it really needed it at all. It was not too bad in any case. So that's the first one done. So that's cool. We'll do another one then. We go here first, sorry, we go here, so the rule is you have to do the integral that comes up. But like number 11 is going to be so easy. Okay, so you expand it out and then you integrate. Cool. So let's just do x squared plus 4 plus 4 over x squared. So that integrates to x cubed over 3 plus 4x minus 4x to the minus 1, I think, something like that. Yeah, sure, whatever. Cool. Next one is going to be, where is it? So we're going to go here, and then we're going to go here. Next one's going to be 183, which should hopefully be a bit more challenging. So I'm in this document now. 183 is, where is 183? Oh, no, way too far. 183, a little bit further up. 183 is going to be here. So, okay, well, sure. So it's 3 log x minus 4x to the minus 1. We just saw that one. And then plus, is that going to be x to the minus 2? And that's it. So that's not hard either. Let's actually get some good ones, please, Google. Random number generator 297, again, getting higher, so hopefully this will be a bit worse. 297 is somewhere in here. 297 is just here. So 2x plus 6. Now, it's still not going to break out the whiteboard, because if you notice, the denominator of that fraction differentiates straight to the numerator. So the answer to this is just log of x squared plus 6x plus 1, because x squared plus 6x plus 1 differentiates to 2x plus 6. So that one is also not interesting. This video, this probably won't make it to YouTube, right? This is just me sitting here reading out integrals. This is not interesting at all. 133. And why are you doing this? So this is it's just reverse chain. Well, sine, the way that sine differentiates is that thing inside of sine differentiates out to the front by chain rule. So well, what differentiates just to sine? Well, minus cos does, I think. So this is going to be minus cos of x squared plus x plus 1, because then the inside of the argument would differentiate to x plus 1, and the minus cos would differentiate to sine. So I also don't think that is very interesting at all. We're going to keep going. This video is going to get scrapped. It's not going to appear on YouTube. 241, but we may as well keep going because Because why not? We might get something good in a second. We might get something good. So, okay, this looks better straight away. This looks actually okay. I mean, it's not, right? Because all it is x squared plus 4x plus 4 over 3x. So we can do some cancelling, right? We can say the first term's a third x, and then plus 4 thirds, and that's it. And then plus, at the end, 4 thirds x to the minus 1, and we can just integrate that, right? Like I've read out before a couple of times. So was the first term like a 6x squared then when you integrate that? And then you have a 4, that integrates to 4x. And then you have a 4 thirds x to the minus 1, so that integrates to 4 thirds log of x. And we are still not getting anything even remotely interesting. This is the rules. I just have to sit here and do this. I have to do the number that comes up. That is the rules. Finally, something actually cool. The cube root of x, root 1 over x. Finally, let's do an actual integral here. So I think this said, I might be wrong, but I think it said the integral of the cube root of x, was it plus 1 over x? There was a times in here, I think. Hang on. It was such an unusual integral. It was x times root 1 over x. X times. Well, I can replace that there. X times root 1 over x. Okay, so actually something fun. So root 1 over x, I think just a bit of manipulation here works. That's x to the minus 1. Rooted is going to be x to the minus a half. So the inside is x times x to the minus half, which is x to the half. Because that's a 1, you add the powers, and then we're doing the cube root of that, and the cube root, of course, is power of a third. So that's going to be x to the 6th, and then we just have to integrate x to the 6th to get 6/7 x to the 7/6. And that'll be our answer. It turned out that that one actually wasn't that interesting, but it was much more interesting than all of the ones that we had before. 81, what are you doing to me, Google? What are you doing to me? This is the least interesting video that's ever been made. But whatever, it's only been going 7 minutes, so we're just going to keep going. We're just going to keep going. X squared log of x. Okay, so we're thinking of a few things here, right? Integral by parts is clearly a thing that could potentially go well. So let's have this. Let's have a go at this one. I mean, it's the rule. We have to do it. It came up on the random number. X squared log of x is the question. Now, I don't really want to integrate log of x. I do know the integral is x log x minus x, but I don't really want to do that. What I'm going to do is I'm going to what am I going to do in that case if I don't want to do that? Because I don't really... Oh, I do want to integrate this, don't I? I'll integrate this a couple of times for x cubed over 3 and keep the other one the same, and then integrate it again for x cubed over 3 and differentiate the other one for 1 over x, that this one differentiated. Slam the minus integral sign in the middle. And the reason, of course, this goes really well is because this term is the same, right? X cubed over 3 log of x. And then we minus, and then of course this cancels with this to make a 2. We raise it to a 3 when we integrate, divide by 3, and we end up with a 9. And yeah, cool, that's that. So now we keep going. Usually we do like 5 integrals. I think we're close to 379. I think we're close to, I don't want to say how many we've done. It seems like quite a lot just because, yeah, they haven't been very good. 379 is here. Oh, it's a hyperbolic. Fantastic. We haven't seen a hyperbolic in ages. Cosh over cosh plus sinh to the power 3. So it's integral. So cosh over cosh plus sinh. Now, as I'm writing this, and that was all to the power 3, I believe. Now, as I'm writing this, I'm really thinking here. Cosh plus sinh is just e to the x, because by definition, cosh is the odd part. Sorry, it's the even part of the function e to the x, and sinh is the odd part. So I think this is just, and of course, cosh of x itself is e to the x plus e to the minus x. All over 2. If you then say that sinh is the same thing but with a minus in the middle, then it becomes clear why the two things added together, e to the x. But I think therefore we have the integral. I can put the half outside. That's representing this half here. Now e to the x cubed on the bottom is e to the 3x, and on the top we have e to the x plus e to the minus x dx. And of course, at this point we can cut the fraction in half here to say this is the integral. E to the x over e to the 3x is e to the minus 2x, and then plus e to the minus x minus 3x is minus 4x. And both of these functions are super easy to integrate. We're going to have minus, we're going to have a half, n. Thank you. We're going to have a half into minus a half e to the minus 2x minus a quarter e to the minus 4x. Close brackets. Good. We will do one more or two more, or usually I try and make these videos between 10 and 15 minutes. It's been 10 minutes so far, so 483 is our next one. Another bigger number, which is nice. 483. Where is it? 483. There it is. Oh, this looks kind of interesting actually. So that's cool. We're getting some after a lot of pain. So it was e to the x, and then it was root 9 minus e to the 2x, I think. So let's write it down, make sure we're right. E to the x over root 9 minus e to the 2x dx. I'm going to check that's right, because this feels like one of those ones, if you wrote this down wrong, this might not be fun. Okay, so it's going to be this. We've got it written down right. I'm going to get rid of this because it's annoying me. Okay, so how do we go ahead and do this? Initially, we're thinking substitution, right? The u equals e to the x. The reason that works well is because, just like in the very first question we did today, I think I'm going to aim to get rid of that there, because if du is also e to the x, because it just differentiates to itself, then when we divide that, it's going to go underneath this, and then the dx will turn up underneath in here, and it will cancel with this one here. So we'd end up with roots. So we'd end up with the integral of 9 minus, now e to the 2x, of course, is just what happens when you square both sides. So this is a u squared, and then we'd have a du. Now, unfortunately, this is the point in the video where I have to admit that I cannot remember which integrals are which. So are we stuffed? Are we stuffed, or do I need to do this properly? I guess I should probably try and do this properly. For example, if I say that u equals 3, should we go with cos x? Because then u squared is 9 cos squared, and then we'd end up with a 1 over 3 into root sine squared of x. And then, of course, du is 3 sine x dx. Oh, sorry, not sure what's happened there. No, I don't want to get the camera out. No. What is going on? Can I just continue? Okay, I'm not sure what's going on there. Turn that off. There we are. Okay. Dx over here. Yeah, with a minus, I guess, because that differentiates to a minus. So then we'd end up with, what do we end up with? So when we put that in, we'd have a, I've gone back to x's, but that's fine. So this will be a minus 3 sine x dx here. So that cancels with that. That also cancels with that. We're now just doing the integral of minus 1 dx, which is, of course, minus x, which then, now x is the same as u over 3 arc cos, I believe. And then u itself initially was an x. It was an e to the x. So I think this is arc cos of e to the x over 3. Probably got that wrong. I've also missed a c there. But yeah, that'll do. Thanks for watching, and I'll see you next time.